Himachal Pradesh, India's gateway to the Himalayan ranges. Mountainous terrain and stunning vistas make for a tourist's delight. But flowing through these valleys is the key to unlocking India's energy potential, the river Sutlej. These waters are vital to driving the 5th largest power market in the world. In fact, India's hydropower potential is immense. If tapped, it can generate nearly 149 gigawatts power. But in the race to harness this energy, who is willing to brave the mighty Himalayas?
हाइड्रो क्रिएट करने हैं तो हजारों साल का जो जियोलॉजिकल स्टेटा है उसको हम टच करते हैं। पोटेंशियल अभी देश में बहुत है हाइड्रो। अभी 1,20,000 मेगावाट के प्रोजेक्ट्स लगने हैं, तो इसके लिए दिल बहुत बड़ा होना चाहिए एग्जीक्यूशन के लिए।
There are no half measures in the founder's vision. An approximately $1.5 billion state-of-the-art hydropower project with a capacity to generate 1,000 megawatts. Once completed, it will be the largest hydropower station ever to be constructed by an Indian private company.
When organization was thinking of implementing Karcham Wangtoo project, all of us were determined that let us create an aggressive timeline. So we thought let us keep a time frame of 5 years and then we will work out whether we can better it.
Now, with the clock ticking, it's all about finding the perfect location. At first glance, the tiny hamlets of Karcham and Wangtoo seem an unlikely sight to realize an ambitious megastructure vision. Surrounded by jagged peaks, prone to sub-zero winters and accessible only by steep mountain roads. But when it comes to the science of generating hydropower, this valley is tailor-made. The river Sutlej provides the mass of water. The steep gradient between the proposed dam site and the power plant provides the ideal head. The main dam at Karcham will divert a mass of water from the Sutlej into inlet gates. Water will then travel along the nearly 17-kilometer-long head race tunnel, or HRT. From here, it's a steep drop through a height or head into the turbines of Wangtoo's powerhouse. It is here that the river's kinetic energy will be transformed into electricity. Further onwards, the river Sutlej will flow out through the TRT, or tail race tunnel, back on its original course. With the blueprints in place, it's time to set the works in motion. Strong winds blow across an intimidating landscape, and it's imminently clear setting up this construction site is not for the faint-hearted. In order to realize this onerous task, the builders commissioned their top commander to set up base camp for the men and the machines needed to build this megastructure. Brigadier Upal brings over 35 years of experience in the Indian Army to the Karcham Wangtoo project. Almost immediately on reaching the site, he knows it's an uphill battle.
In the mountain, it's very rare to find a flat piece of ground. A river flowing and hardly a bank of the river and the bank was also very low, just running along the riverbed. So to create a camp in a vicinity of this kind, for a terrain of this kind, we had to literally fill up the whole place with a large amount of boulders, stones, rocks, sand to bring up to the height what it is today.
In just over 1 year, the main camp at Wangtoo and 7 smaller ones are ready for their occupants, all 14,500 of them. As the brigadier rallies troops at the high-altitude base camp, in the plains below, other contingents prepare for a treacherous journey. Besides vital supplies, these trucks will also carry million-dollar equipment as heavy as 50 to 80 tons. All this on some of the most dangerous roads in the mountains. Keeping steady pace, the trucks are sent to Karcham and Wangtoo. Meanwhile, in the valley below, the task of harnessing the Sutlej begins. Deep in the gorges of Karcham, excavation for the dam's foundation is scheduled. But before digging can begin, there's a river to divert. The Sutlej must be temporarily diverted through a 541-meter diversion tunnel. Two cofferdams will help maintain the river's new course, preventing water from seeping into the main dam's construction site. Cofferdams are temporary structures, often made from rockfill, which can get washed away with every monsoon. But with the clock ticking on the project's record-breaking deadline, this dam site requires a sturdier fortress. Designers create a cement-reinforced structure that won't need to be rebuilt after the rains. With the Sutlej successfully diverted, it's time now to build the dam. At the helm of affairs is Civil Works in charge K.K. Sood. He spent the better part of his life building hydropower projects across India.
When I started my career about 33 years back, 100 megawatt project used to take 15 years for completion, and about 10 to 12 years back, project of magnitude of 300 megawatt, it used to take about 7 years.
Now, K.K. Sood's men must ensure that construction on a 1,000 megawatt project is completed in under 5 years. But as the team prepares for dam excavation, it realizes that plans set by men are often overlooked by nature. Geological tests reveal startling information about how deep the dam's foundations would need to go.
हमने कोरिंग होल मारे to extract the cores through core drilling machine. तो जो हमारे असेस में निकला 52 मीटर के बाद हमारे पास साउंड रॉक प्रोफाइल है, जिसमें हम अपनी डैम फाउंडेशन रख सकते हैं.
Most dam foundations in similar locations go no deeper than 30 to 40 meters below the riverbed. At Karcham, the difference between the riverbed and the dam's deepest foundation level is measured to 53 meters. Engineers now stare at the prospect of going at least 10 to 15 meters further underground. They are faced with two choices: delay the date of completion and miss the deadline, or make way for the big guns of construction. Within the stillness of this North Indian landscape, there's frenetic activity underway. The foundations of the main dam at Karcham have reached depths of over 50 meters below the riverbed. Removing the excavated material is a major challenge, one that conventional dumpers literally can't rise up to. So the builders call in the big guns of construction, 6-wheel drive articulated dumpers. Their combination of flexibility with pure muscle allows loads of up to 37 tons to be carried up a height of 1 meter along a length of just 5 meters. While these machines expedite excavation, engineers turn to another pressing concern: securing the cofferdam at depths exceeding 50 meters below the riverbed. The design team takes a bold decision: large-scale cement grouting of the cofferdam's foundation up to depths of an extraordinary 67 meters.
We opted for jet grouted columns. This is nothing but interlocked row of columns of concrete constructed by drilling holes. We lowered pipe with a nozzle and pumped the cement grout at a high pressure. So there was overlapping of the columns and a continuous impervious curtain in the riverbed was available.
As one problem is solved, another one quite literally seeps in. Work on the 1,000 megawatt Hydel power project is moving along smoothly when a minor trickle in the cofferdam becomes a deluge. The river Sutlej seeps into the main dam site, threatening to undo 2 years of excavation and building. Dam in charge Sanjay Gupta rushes to the site.
अचानक कॉफर डैम के नीचे से सीपेज रेट ऑफ सीपेज बहुत ज़्यादा बढ़ गया था, जिससे हमें डाउट हो गया था कि ये कॉफर डैम के नीचे का मटेरियल वॉश आउट कर देगा। वॉश आउट होने से कॉफर डैम कोलैप्स कर सकता था, और अगर कॉफर डैम कोलैप्स कर जाता तो रिवर का जितना भी पानी था वो डैम पिट में घुस जाता, जिससे हम अपने शेड्यूल से एटलीस्ट 1 साल और पीछे चले जाते।
It's a battle against time as Gupta and his men lead the charge.
एक तो हमने सबसे पहले जो हमारे पास सबसे बढ़िया डंपर वॉल्वो थे, उसमें बोल्डर ले जाके उसमें डंप करना चालू करे, जहाँ से सीपेज आ रहा था, जहाँ से मेन मटेरियल वॉश हो रहा था, और उसको डोज करते हुए वॉल तैयार करनी चाहिए।
Bulldozers erect a wall of rock, while dewatering pumps work round the clock to stem the flooding.
Everybody works there. हर आदमी है, टॉप मैनेजमेंट, मिडल मैनेजमेंट, लोअर मैनेजमेंट, अराउंड 200 लेबर्स। That was something different. So you can say total satisfaction.
24 hours later, the worst is over. The team has managed to convert a serious roadblock into a badge of honor. But there are bigger accolades to be earned, ones that will truly render the project a megastructure. Engineer Ashish Bajaj picks his steps carefully inside the dam's intake sedimentation chambers. Sedimentation is a process that removes suspended solids from water. This cavernous expanse is the project's crowning glory. Its task: taking on the Sutlej's silt menace. The Sutlej carries large amounts of river sediment in its waters. This spells murder for power turbines, where particles as tiny as 0.2 millimeters can shut down massive hydel plants. To avoid this fate, water is made to enter the tunnel system 15 meters above the riverbed. This ensures that only surface water with reduced sediment flows in. To seal the deal, designers create 4 adjacent sedimentation chambers.
Once the dam is filled, from intake it will be 4.5 meter per second velocity of water that will come in. And in sedimentation, that chamber that has been put down up to 0.3 meter per second, so that the water gets stagnant out over here. And there are 53 numbers of cone, 53 numbers of hoppers, through which these particles will get down to the flushing tank.
Gravity guides silt through these 5.25 kilometer long flushing tunnels, back into the river downstream. These are the longest flushing tunnels to be found in the Indian hydropower sector. But the record-breaking streak doesn't end here. These sedimentation chambers have a design discharge of 504 cumecs. That's a whopping 504 cubic meters of water per second.
This is world's largest chamber volumetrically, and most probably this will be going into Guinness Book of World Records. This is 424 meter long with 70 meter transections. That makes it 494 meter with a 35 meter depth and 18 meter wide, all lined. This whole chamber has been reinforced. This is all RCC lining done out over here.
With the world's largest sedimentation chambers installed, builders have overcome yet another Himalayan challenge. As distinct from large storage dams, the Karcham Wangtoo Hydroelectric project is a run-of-the-river facility, where the Sutlej is diverted temporarily to run electricity-generating turbines. Then it is restored back to its natural course in the Himalayan gorges. Part of this design involves large-scale tunneling into the mountain. Over 44 kilometers to be precise. Of these, the headrace tunnel is critical to the power equation. It's also the longest. The headrace tunnel, or HRT, is 17 kilometers long, running along a downward slope inside the mountain face. Water taken from the intake hurtles at 4.88 meters per second through a cylindrical tunnel of 10.5 meters in diameter. By the time it reaches the head of the tunnel, it gathers enough kinetic energy to power a 1,000 megawatt power station. But before it can do that, there's some heavy-duty boring to be done. This is the muscle for boring through mountains. Called boomers or jumbos, the project has commissioned a whopping 39 machines on site.
The process of advancing is, first of all, we drill holes up to a length of 4 meters with the help of drill jumbos. Then we charge it with explosive, and then the entire charge is fired. After every fire, we get an advance of about 3 meters.
For a while, the tunneling team makes good time on advancing along its tunnel path. But things are about to get heated. Soon enough, the builders receive startling information. Workers have run into extremely high temperature zones near one of the approach tunnels, or adits. Hot steam is gushing from cracks in the rock face. Extreme humidity and vapors have turned this area into a virtual pressure cooker. What's going on inside the mountain? The answer will come from an elite group of mining detectives. Builders bring in experts from the Central Institute of Mining and Fuel Research, or CIMFR.
हम लोगों ने ऑडिट 4 से इंटर किया और पूरे एरिया को थर्मली स्कैन करते गए.
Temperature varied between 60 and 98 degrees. Lot of vapors, high temperature.
उस केस में वहाँ मोर देन 2 और 3 आवर्स स्टेबल रहना बड़ा मुश्किल था और ऐसा लग रहा था कि आप गिर जाओ.
Investigators trace these extraordinary circumstances to the Himalayas' fractured geology.
We could arrive to a conclusion that it may be magmatic heating. The earth crust, it is floating over the very hot magma. So somehow, due to some cracks, this heat is being dissipated. Because it is continuously being released, that means the source has not been exhausted.
Tunneling is immediately halted. Under such high temperatures, there's danger of detonators and explosives blasting prematurely. Timelines set for this ambitious project seem to be going awry. Things are getting heated in the Himalayan hamlets of Karcham and Wangtoo. Construction crews at India's largest private hydropower station are facing a pressure situation rarely encountered anywhere in the world. Tunneling into mountains has revealed intense hot zones with temperatures as high as 98 degrees Celsius. The construction team devises a precisely timed operation. They can't afford more than half an hour to clear an area. Workers rush in and spray cold water on the rock face. Detonators are placed 100 meters away from the rock face. Then the blast is set off. Never before have such extreme circumstances been encountered and overcome in India. Meanwhile, across the valley, other heights are waiting to be conquered. This mountaintop is the site for the Hydel project surge shaft. It poses a unique challenge for project engineer Samrinder Kumar.
मैं नीचे से मैं देखा कि ये सरशाफ्ट का लोकेशन, ये मुझे बताया गया कि ये सरशाफ्ट का लोकेशन है। तब मेरे माइंड में मेकअप हो रहा था कि एक चैलेंजेबल जॉब है और मुझे हर हाल में इसको करना ही है।
Samrinder's team must commence construction on the straw-like shaft that's crucial to ensuring water balance for the entire power station. When water gushes through the head race tunnel, it passes through pressure shafts and drops vertically down into the powerhouse, turning turbines. The surge shaft is a safety feature to accommodate excess water in case the turbines are shut down for any reason. Built at the same elevation as the main dam reservoir, the shaft also maintains pendulous pressure balances throughout the system. Basic physics of the surge shaft is simple, but building one is far from it.
हमने ये प्लान करना था कि अप्रोच रोड भी बनाने हैं और हमें काम स्टार्ट भी करना है फर्दर, ताकि हम टाइम सेव कर सकें।
Wasting no time, a group of expert climbers is roped in. Scaling the mountain face, they carve out tracks for a pathway. Inch by intrepid inch, they construct a foot ladder made from iron rods. Workers climb the 185-meter slope to build the approach road and start work on the surge shaft. Their goal: to complete the approach road without losing a single day of construction. Piece by piece, blueprints imagined by the project's design team are being raised from ground up. Meanwhile, the biggest piece in the power structure is being constructed deep below. Far within the cavernous recesses of Himalayan peaks lies the underground powerhouse of this 1,000 megawatt facility. This is the heart of the Karcham Wangtoo project. It's where the gushing might of River Sutlej transforms into electricity. Keeping this heart beating are 4 state-of-the-art turbines, each capable of generating 250 megawatts of electric power. Electricity generated in these machines will travel to the transformer hall. Here it will be stepped up, which actually means boosting the voltage of electric current. This stepped-up current will then be evacuated out of the powerhouse through a switchyard into the national electricity grid. At Karcham, Wangtoo, veteran hydroenergy engineer Kanti Prasad oversees powerhouse construction and its most critical component, the turbines.
The total weight in this case, in this turbine, in this generating unit, would be more than nearly about 700 metric ton.
With the powerhouse turbines yet to be commissioned, Kanti Prasad's most immediate task is lowering its massive components into these hollow chambers. It's heavy lifting that will require heavy infrastructure. This is one of the largest pieces of equipment to be used in the project. The Electric Overhead Travelling, or EOT crane. This mega crane can install loads of up to 275 tons with an astonishing 1 millimeter precision. But it's not just the numbers that are striking. Ingenious designers have used the cavern's natural attributes to create history.
We decided to make a ledge which has been done for the first time in the Himalayan geology. We have made mushroom type of structure in the rock itself, and we have created a crane beam right on the ledge. And on that ledge we have laid our rails, and on those rails our crane, EOT crane, is operating. This way we were able to get the crane on day one when we reached at the bottom, and we were able to erect our machinery much earlier.
With the EOT crane up and running, Karcham Wangtoo's power generating units look set to beat their deadline to completion. Next on the agenda, evacuating the power out of the plant through the switchyard, down the mountain and into the homes of the public.
Start maintenance for the peak period.
At Karcham Wangtoo, works for the 1,000 megawatt Hydel project are nearing completion. It's taken just about half a decade to become one of the fastest builds in the history of Indian hydropower projects. Electricity must now fan out across the mountains to reach the energy-hungry populations of India. This is the final leg in the power journey. It involves setting up 217 kilometers of transmission lines from the peaks of Karcham and Wangtoo to Abdullapur in the plains of Haryana.
The higher altitude we are traversing, it is around 2,450 meters. The difficulties in this area is that we have very steep slopes where the positioning of tower is itself is a problem. So to negotiate that slope and to cut that slope and lay the tower, sometimes the slopes are so steep that a single person cannot stand on that point. In my opinion, this transmission line is the one of the toughest line which we are laying in India.
In the absence of motorable roads, over 500 transmission towers must be built by hand, with materials and equipment transported manually across the harsh terrain. Collectively hauling the nearly 50 tons required to build one single tower, it's often a steep climb through uncharted territory. But where footpaths end, workers must take to even more dangerous ways to cross the valley. This is how workers transport building materials and equipment between two transmission towers, sometimes across distances of over a kilometer long. Once the towers are erected, 400 kilovolt conductors and insulators weighing approximately 30 tons are pulled manually to be strung up on the towers. 7,000 workers have banded together to create a network of transmission towers collectively weighing a massive 25,300 tons. The day is not far when the fruits of their labor will be realized in full megastructure glory. Inside the completed powerhouse, it's a very big day. It's time to lower the multi-million-dollar rotor into its turbine chamber.
ऐसा है रोटर का वेट एक्चुअली 475 टन लोड है.
High precision EOT cranes take center stage to execute the job.
ये जो बीम है बिल्कुल प्रिसाइजनेस रहना चाहिए ताकि जो उसमें लोड आता है बीम पे वो एग्जैक्ट सीधा उठ जाए ताकि अनबैलेंस ना हो.
All eyes are on the cranes. It's a very precarious operation, with nearly 500 tons of metal and millions of dollars hanging in the balance.
This is the heaviest component of this unit, and it is very, very important that it should be taken, it should be lifted and lowered in the pit very, very carefully. Otherwise, a small mistake can play havoc with the machine as well as other components, because the whole load is coming on the cranes.
Slowly but surely, the rotor inches closer to its destination. On the ground, anxious engineers wait to receive the mammoth component. For the powerhouse team, this is a cliffhanger moment that leaves no room for error. As it lowers, its trajectory is mapped to exact precision. Not a millimeter must be out of sync.
It's like a 3-hour movie which you are watching in the theater. Now we have come very close to the commissioning of this unit.
Upstream at the main dam site, the gates of the dam are lowered, and the reservoir of the Karcham Wangtoo hydroelectric project begins to fill up for the first time. Inside the powerhouse, pre-commissioning checks are at a critical stage. There can be no room for error as the water makes its way across the 17-kilometer head race tunnel to reach the powerhouse's threshold. For the first time, huge butterfly valves are opened to release water into the pressure shaft. All systems are ready to go. It's time for JP's visionaries to set the wheels of their dream project in motion.
It is now on record that in the Indian Fire Plane, Karcham Wangtoo project is the largest project got commissioned, whether it was private sector or a public sector space.
The JP Group's founder touches down at the remote Himalayan location to inaugurate his company's latest milestone. Divine blessings are called upon to anoint the cutting-edge facility. The hall crowds with the faces of all those who have worked tirelessly to complete construction in a record time of a little over 5 years. At a specially appointed hour, Kanti Prasad formally commissions the first turbine. The Karcham Wangtoo project is one of the group's crowning achievements.
I am one of those power engineers who had the privilege of working from 2.5 megawatt to 250 megawatt. So you can imagine my own happiness.
With the 4 turbines working to full capacity, the business of powering a nation gets underway.